Welcome back. Let's share. And I hope you're looking over here. Yeah. Before we can do the next problem that we already outlined, we have to name these molecules and answer this question right here. What is meso? Let's name this molecule from left to right. And let's name this molecule from right to left because I think you get a group on 2 and 4 either way. And you're going to see something interesting with their names, and then I'm going to show you something interesting with their structures. Okay, they're definitely mirror images of each other. You can't disagree. Bromine towards the mirror, H away from the mirror, bromine away, wedge, yeah. They're both 2,4-dibromo. Yeah, let's just do it this way. 2,4-dibromopentane. They're both that name. And going left to right, we have a stereocenter that is R on the left. To R. And bromine CH2 to CH3, S on the right. And this one is 2S 4R. I hope you notice that if you name this one going the other way, it is the same as this one. You want proof. This is this one for sure. I just copy pasted it, and it's also, whoa, wait, they're the same. The same molecule. How can they have different names? Well, the fact is, they didn't have to have different names. You could have numbered this one 1, 2, 3, 4, 5 that way. So one way to see if you got meso is to go ahead and name it. And if you can name it following all the same rules and get the enantiomer's name in the same molecule, which we just did, then it's a meso molecule. But the technical definition isn't exactly that. Definition of meso is 2 molecules. No, it's not even 2. A molecule. A. There's not 2 molecules here. Don't pretend that there's 2 molecules. A molecule. It's got more than one stereocenter. Multiple stereocenters. It can have even more than 2 stereocenters. That is identical to its mirror image reflection. BTW, you guys love that. Meso molecules are, if you follow your definition of chiral, is a molecule that's not superimposable on its mirror image. So if they are superimposable, they're called achiral. Any molecule that's superimposable on its mirror image is achiral. Mesos are just one specific way to be achiral. I'd like to point out the molecule water is not meso. I want to make sure I draw an O that looks symmetrical like it's supposed to be. There's water. Copy paste means the next molecule is the same molecule. And look, it's the mirror image. Water is achiral. There's not. That's a bad mirror. But it's not meso. Doesn't have a single stereocenter. A as a prefix means without chirality. This one is also meso, achiral and meso, because it has multiple stereocenters. And the thing to see about a meso compounds, they have what's called a mesoplane inside the molecule. It cuts this CH2 right in half. There you go. It cuts the CH2 in half. You see a BR across the mirror from a BR, both on a wedge. H going in behind the mirror, or behind the page, sorry, looking at each other across the mirror. C sees a C, and CH3 sees a CH3. So what's the purpose of doing this? Yeah, meso is a molecule with multiple stereocenters that are identical to its mirror image reflection. And this molecule we're about to draw, the first one is meso. Let's just start with cyclooctane all over again and pretend we don't have a bond straightening tool. It didn't connect those two, but good enough, right? So there's a cyclooctane. If you make carbon 1 over here, you got a dibromomethyl again. 2, 3, 4. And we have a tert heptyl and a tert heptyl. And we wanted the 4 on a dash. And an adjacent on a wedge. And it went 1, 2, 3, 4. R. I like to point out, if it's going to have an internal mirror plane, which it does, this time, wow. This time it's equidistant between the two CH2s. What's the mirror image of an R? It's an S. It's meso. Don't draw the mirror image. That was our strategy on our next molecule. Don't do it. Are you going to lose points? No. I'm not going to give you points when you copy the same molecule again. Why are you copying the same molecule? Because the meso molecule is the same as its mirror image. But if you follow the strategy for molecule 3, which was to do a single switch on one stereocenter, you will have a new molecule that is not meso, cannot be meso in any universe. I'll copy this stereocenter as is. And make sure it's heptyl, not hexyl. 4, 5, 6, 7. Good. And I'll do a single switch here to put the tert heptyl and the bromomethyl here. And the dash still here. You did nothing on the first stereocenter, a single switch on the other one, and draw its mirror image because it'll be SS. And same distance, dash. Towards the mirror, upwards on a wedge. straight up, left or right for the BR doesn't matter. Straight up, tert, heptyl, and on a wedge, up, away from the mirror. Mirror image of an S. R is an S, and same for both stories. And you currently have 3 molecules. You need 3 comparisons. You can do them all in purple. Mirror images. Enantiomers. First stereocenter the same, second different. First stereocenter different, second same. And now you got your 12 out of 12. Just want to point out on the previous page, you had 4 more comparisons and 2 more stereocenters and 1 more molecule. 18 points. You'll have one of those questions on your test. So 12 or 18. And this doesn't give away what the points will be, does it? All right, so that brings to a close this question. But sometimes meso molecules don't look meso. And we'll spend the rest of this segment meso or not meso. It's a good question. Meso, not meso, or achiral for other reasons. Not meso. I don't know if I like the question. Meso should go with achiral for other reasons. Little hasty there. Not chiral, meso. Chiral, comma, meso, comma, or achiral for other reasons. There we go. So we'll start with a simple one. And that one is chiral. How come? Well, there's only really one answer. It's not superimposable on its mirror image. That's the only definition of chiral. If you draw its mirror image and tried to put them on top of each other, they wouldn't match. Okay. There's only one stereocenter. Typically, if you have a molecule with a single stereocenter, it's going to be chiral. But if I have a similar molecule like this one, and I have this, that's a very badly drawn H. It's pretty easy to see that will not be meso, right? But sometimes it's not easy to see that. That's an O up there. Both of those are chiral. Let's talk about it. One way to do the meso, not meso, and not be able to see the mirror plane, even if there is one, is just do the stereocenters. And I'm going to pretend you guys are experts now. I know you're not yet, but you have to keep practicing. The stereocenters never go away. And this first one is S. Verify that on your own. The second one's also S. I know right now this molecule is chiral. It's got multiple stereocenters and they don't cancel each other. How do I know they don't cancel each other? They're not opposites. It's chiral. Plus, if you tried to put a mirror plane through here, it would have to be here, right, to be symmetrical. You got a H looking at an OH, the same orientation away from the mirror towards me. And you got an H here across from an OH, the same orientation. They're not matching. It's going to be chiral. Similarly here, same stereocenter up here. This one you can do directly and it's S. It's also chiral. Sometimes it's not obvious though. This one is not chiral because it's meso. No, they don't always have to have alcohols. Just alcohols are easy to deal with. This one has stereocenter here, stereocenter here. Stereocenter on the left is R. On the right, it's S. You could do the work and say it's not R, therefore it's S. And say meso. You could do the work that's not necessary and do a sigma rotation. Take you to the beginning of today's lecture. Doing flips and stuff, which not everybody can do. If you do a sigma rotation to get this methyl straight down, then that brings the OH from behind the page outwards. Once again, don't be forcing yourself to try to do this. This one you can definitely see meso, can't you? I drew the meso plane for you. You didn't need to. It's R over here. You did the work when you did the R and the S. It's got the same name both ways. Don't even worry about naming alcohols. It would be the same name. Alcohol on 2, alcohol on 3. Start over here. Alcohol on 2, alcohol on 3. Same chain. If you have as many R's as S's, then they're symmetrical from each other. Meso. If they're not meso, they're chiral. Chiral will have both stereocenters the same. Let's do another one. Let's do this one. Mm-hmm. How do I know this one's meso? First of all, just because it has wedges and dashes doesn't make it a stereocenter. How do I know it's not a stereocenter? Oh, and once again, I apologize to the student on the problem set. He had 2 of his bridges in his bicyclo molecule with the same size because I was using those letters M. He didn't have stereocenters in his, so all he had to do was say, just give the name without, that was you, huh? Give the name without stereocenters. which was fine. Just, it's hard to make 40 different problems, isn't it? This one's meso. I mean, you can kind of see it if you cut the OH in half, and in the same plane, there's the H, you know, and you can do the R and S. This one goes S, and this goes R, and it's kind of symmetrical, right? Aldehyde on the extremes, alcohol, second one in. CH2 is the same as CH2. So this one's meso. And then we have, so it's achiral because it's meso. Then we'll have a similar molecule like this. You guys are really going to think it has to be OH, aren't you? Let's put a BR here. Is that meso? You can cut it in half. No, that's just achiral. Why? Well, it doesn't have multiple stereocenters, so it can't be meso. It has 0 stereocenters. It's got propyl groups on each side. Those are identical. Don't call it meso, but it's also achiral because there's one. There's no carbons with stereocenters. Which I sadly want to point out, that's not a definition of chiral. But as far as you know so far, chiral molecules have to have a stereocenter. That is not a definition, and it's not true. I'll prove it right here at the end of this segment here. Chiral molecules do not have to have, isn't English fun? Those halves are different. Do not have to have. Have here is like is in necessary, and have here is like possessive. I just like poking fun at my own language. Do not have to have stereocenters. For example, if you have a molecule that has a pi bond here, and on the same carbon, a pi bond the other way, you do remember that the pi bonds cannot be using the same orbitals here as they are here because the carbon can only use those in one direction. So if I use the py, that means the plane of the sigmas has to be in the z plane, 90 degrees from y. That'll make this, it's still trigonoplanar. And I'll just put like an H here and a CH, I don't know, we can use bromine again, iodine. And that means you use py here. That's why these are in the z plane. Now, you can't use py here. What are you going to use? Pz. So the plane now will be the x plane, the xy plane for your sigma bonds. I can put a CH3 up here. H here. There's not a single stereocenter in this molecule. You're saying, wait, Dr. Whitaker, it's got a wedge and a dash on it. It might be a stereocenter. There's only 3 things on there. What's the definition of a stereocenter? Tetrahedral atoms with 4 different groups is what you know so far. It's more general than that. An asymmetrical atom is the only definition. Okay. But for you, it has to be a tetrahedron in this course for you to have a stereocenter. This molecule has a mirror image that's not superimposable on it. I'll draw it, and I'll prove it. Okay. I'll try to prove it. It's hard if this is one where being in lecture in person is a lot better than doing this on a screen. To prove that it's not symmetrical, you're going to have to take it, it's here, and flip it and try to put it on the other one, right? You're going to have to flip it this way. That way, if I flip this and try to put it on here, the methyl will be on top of the methyl and the H will be on top of the H. But what happened to the iodine, which used to be away from the screen when you flip the molecule? Now it's towards you. So that iodine will be on a wedge when it flips over to the other side here. And the H will be on a dash. It'll be on top of an I. Those are enantiomers. And the molecule doesn't have any stereocenters. That yellow doesn't show up that great, I know. Enantiomers without any stereocenters. So the only definition of an enantiomer is it's not superimposable on its mirror image. And the only definition of chiral is a molecule that's not superimposable on its mirror image. Enantiomers are two molecules that are non-superimposable mirror images of each other. They're very similar definitions, but one's only talking about one molecule, and the other, enantiomers, is talking about a pair. And I will pick up after this break, and we'll finish. Well, we won't quite finish chapter 3, but we'll be close.